In this video, we'll write the electron configuration for Cd and Cd2+. The first thing we need to do is figure out how many electrons Cd has. So we'll write the electron configuration just for this neutral cadmium first, and then we'll just remove 2 electrons and get Cd2+. So the first thing we need to know how many electrons we have for Cd. It's right here on the periodic table, the transition metals, and we see that 48 there. So that 48, that's the atomic number. All these elements are neutral, so the atomic number, which represents the number of protons, that equals the number of electrons. Positive and negative, they balance out, and it's a neutral atom here. So we have 48 electrons. So we're going to write an electron configuration with 48 electrons. There's 2 ways we can do this. So the first way that you might be familiar with is we can use this chart here. So let's start with this, then we'll do another way that's really useful to think about this. So this chart here is kind of mechanical, really, in a sense. We just keep following these arrows. So we need to get to 48. We have 1s2, s holds up to 2, 2s2, 2p, which holds up to 6, 3s2, 3p6, 4s2. Then from the 4s, we'll go to the 3d. That's just the way it's written. So we're going to just do that, follow it kind of blindly here. 3d to 4p, and from the 4p we go to the 5s, and at this point we've used 38 out of the 48 total electrons we have. So we need to add 10 more electrons from the 5s here to the 4d. D holds up to 10, so we're going to fill it up with 10. And this is the electron configuration for Cd, the neutral atom, based on this chart here. So this electron configuration, we have all of our orbitals and energy levels here correct. Let's take a look at another method, and then we will need to tweak this just a little bit. So here's the periodic table, and it's broken up into these orbital blocks, which is really nice because it shows you that the periodic table really is organized quite well when it comes to electron configurations. So here's how we do it. All of these end in S1, all of these end in D1, all the way up to D10. These end in P1, P2, all the way up to P6. P's hold up to 6 electrons. So we just follow across as the atomic number increases. 1s1, 1s2, this is full. 2s1, 2s2, that's full. We go over 2p1, 2, 3, 4, 5, 6, that's full. And so on, up 3s2, 3p6, 4s2, and from our 4s2, here we go to the 3d all the way up to 10. D holds up to 10. 4p up to 6, 5s2, and then here we are, 4d all the way up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 4d, 10. So you can figure the electron configuration out if you have these blocks memorized, and it's a lot more meaningful. So let's do this. We do need to tweak this a little bit, and then we'll just do the electron configuration for Cd2+. Often you'll see the electron configuration for Cd written like this here. It's probably a little more correct to put the 4s after the 3d here with these transition metals. Same up here, 5s after the 4d. That's a little more accepted. It also puts this 5s2 out on the end. These are the ones, these s orbitals and the p orbitals, those are the ones we lose when we form the chemical bonds usually. So we have this configuration here. So this is our configuration for Cd. If we wanted to do Cd2+, let's copy this. Since this has a 2+ ionic charge, that means it lost 2 electrons. Electrons are negative, it lost 2, now it's Cd2+. So we just need to lose 2 electrons, and we're going to lose these 2 electrons here out on the end. Often we'd lose them to another atom, and that would form a chemical bond. So these are no longer part of our configuration here, and now we have the ion Cd2+. This is Dr. B with the electron configuration for Cd and Cd2+. Thanks for watching.